So, if you read the chapter example was about cereal boxes and getting like trading cards out of them. 20% of the cereal boxes contain a picture of Simone Biles, 30% of Megan Rapinoe, and the rest were Serena Williams. Suppose you buy 5 boxes of cereal. Estimate the probability you end up with a complete set. What does the complete set mean? One of each, right? So you have to remember that you are simulating a reality situation. I'm going to buy 5 boxes of cereal, and I want to know if I can get one of each, right? So we're trying to simulate buying cereal boxes and getting a trading card. So that's the first step we're going to write down. What are we simulating? It's a picture, it's a little card, whatever. Getting tomorrow. Tomorrow's the great shakeout, so.
For some reason, I thought that, I read it as made in Rapino was 10%. So, I did 0 to 19%, or 0 to 19 was Simone Biles, and then 20 to 29 was.
Okay, so then okay, I see that. Okay, so now remember, we can make our life easier if it's possible to use the digits 0 to 9 instead of 00 to 99. If my percentages are multiples of 10, then I want to use 0 to 9 to simulate that instead of using all 99. Then I can go one digit at a time on my digit table. So 2 is we're going to let 20%. So how many numbers is 20%? How many numbers out of 10?
2.
How many is 2, right? 2 numbers need to represent Simone Biles. So 0 and 1 be Simone. And then 30% is how many numbers? 3 numbers. So you need to go 2, 3, and 4, right? I can't reuse 0 and 1. Those represent getting a Simone Biles card, right? So then 2, 3, and 4 represent Megan. And the rest, which would be 5 numbers, right? The other 50%. So 5 through 9 are Serena. And then I'm going to put, because there's Simone and Serena, I'm going to use the last initial when I go through my random digit table. So 3, I'm going to use a random digit table, 1 digit at a time. Yes?
How come for Simone we're not doing 0 through 19?
Because I don't want to use 100 numbers if I could use 10.
Oh, so you're just splitting it.
Because 20 and 30 and 50 are multiples of 10, I don't need to use 2 digits. I can just use 2 numbers to represent 2 out of 10, 20%.
Oh, and then it makes it on the random
Digit table easier because I only have to look at 1 number at a time. Now, is it wrong to do 0 to 99 and 00 to 19 is Simone, and then 20 to 49 is Megan, and then 50 to 99 is Serena? No, that's not wrong. You would not get marked off for doing it with 2 digits. You just have to explain your process. I need to be able to repeat your work on your random digit table by your explanation. So I need to be able to read your explanation in 2 and 3 and to be able to redo what you were doing. Okay, so that's what you're trying to do. You're explaining to me what you're doing so that I can make sure you did it right. And I usually do. I go through your numbers. Okay, yes, she picked that one right. Yes, she picked that one right. Nope, she messed that one up, right? And so that's what you got to think about. In blocks of 5, because it says I buy 5 boxes of cereal, right? And we're going to record if I got a complete set or not. It's not how many cards I got, it's did I get one of each athlete? Okay. So my response variable, RV is a response variable, is the probability of getting a complete set. That's going to be the percent of time I get one of each. So I'm going to look at a percent. It's not an average, right? What proportion? So I'm just going to record in the end for my trial. Yes, I got a complete set. No, I did not get a complete set.
Does it say the problem, like find the percent?
It says estimate the probability.
So when it says probability, that means percent.
Yeah, what's the likelihood of getting all of those, right? If it said, like the next one is, how many do you need to buy to be pretty sure you're going to at least get one of these? Now, we're not,
Average.
yeah, that's average. Okay. Actually, at least one, or to be pretty sure, is like your maximum. So we'll talk about that in a second. Okay, so number 5 is perform the trials. Okay, so we have to do 20 trials. Okay. Of 5 numbers, yes. So the first number is 8, right? Who is that? Serena Williams. 2 is Megan. 7 is Williams. Megan and Williams. Did I get a complete set? No, I didn't get any Simone Biles, right? So this is a no.
You're allowed to get more of one of the same person, or
I'm buying 5 boxes, and what I get is what I get. The question is, did I get one of each? Yes or no? Okay. So the first trial, where I would write down on my paper, somewhere over here, ooh, that's big, is no. All right. That's my first trial. And then we go and do the next one. I got Serena, and Simone. So that is also a no. Okay, then I have Megan, Simone, Serena. I can end that trial. I mean, I can look at the other 2 numbers. It doesn't matter though, right? I got one of each. So we'll block out those numbers, those 5 numbers, and this is a yes. Okay, because it's another Simone and another Serena. And then trial 2, 4 is Megan, Serena, and Simone. So that's another yes. Okay. Questions about what I'm doing with the random digits. Remember, each number represents an outcome. Yeah.
Does it have to be a certain line?
No, I can start at any line, but we used yesterday a bunch of the lines at the top. So I think like 107 was about where we left off, right? You could pick any side of the paper to start your digits on. On the quiz, you're going to be given a set on the paper, and you'll just use those. Okay. All right, next trial. Williams, Biles, Williams. That's a no. Right? That's Williams, Raponi, and Biles. So that's a yes. So my first 1, 2, 3, 4, 5, 6 are no, yes, no, yes. Let me write those down. No, yes, no, yes. And you're going to continue to do this 20 times. Okay. And then you're going to find the percentage of the time. So how many out of 20 did we get a yes? And then we say, based on our simulation, we expect to get a complete set approximately this percent of the time. Okay, do you want me to finish? Williams, Rapone, this is Rapone, Williams. This is a no. This is a yes. Biles, Williams, yes. So that's another no yes. And now I'll move to the next row. Okay. On your quizzes, I made a worksheet we're going to use to practice. And I put it somewhere. Like an organized person, I put it in the files. Notice that with this, there's actually like some space, right? So you will be given like a set of random numbers like this, and there's going to be space to write your trial and information underneath it, so it's not as cramped as this random digit table, okay? But the random digit table is just so you have them to use for all of the homework and stuff, okay? Okay, so let's say I finished my 20 trials. For sake of time, I don't really want to do 20 because it's a Wednesday. So I'm done with my trials. I got how many yeses? 4. 1, 2, 3, 4 yeses out of 1, 2, 3, 4, 5, 6, 7, 8 trials. So my response variable, remember this is part 6, analyze your response variable, which means calculate your mean or percentage. So I got 50%. If you did 20 trials, it's going to be more accurate. You got about 50%?
It was 50%.
Okay. So then, based on my simulation, our conclusion, based on my simulation, I would expect to get a complete set of pictures 50% of the time. Okay. Is it okay if your simulations didn't get 50%? Absolutely. Right? Every simulation, if we're doing a small number of trials, is going to result in a different answer unless you were using line 107 like me, right? So, and if you were using your calculator, do you want me to show real quick the calculator? Yeah. How would we do this with the calculator? So instead of saying use a random digit table 2 digits at a time, we explain what we plugged into the calculator. Use randint 0 to 9. So math, probability, randint, 0, 9, 5. So because I know that I'm simulating buying 5 boxes of cereal, so I can ask it for 5 numbers, right? And remember that's in the math, and then over to the probability menu. 0, 9, 5. So you write down what you see here. Use randint 0, 9, 5. And then did I get one of each? Yes. Okay. You don't need to write down these numbers on your calculator. You just need to write down yes or no. Right? So that's Biles, Williams, Rapone. We got one of each. Do it again. Right? Do we get one of each? Yes. So that's 2 yeses, and what I'm writing down on my paper is yes, yes. And then I just keep hitting enter until I've done this 20 times. Another yes.
Oh, I didn't do 20.
And there's a no. Okay. Same calculation. How many yeses out of how many trials did you do? Okay.
Wait, what did you say? You go back to 7.
I said, based on my simulation, I would expect to get a complete set of pictures 50% of the time. Okay, and then 18 says, suppose you really want the Simone Biles picture. How many boxes of cereal do you need to buy to be pretty sure of getting at least one? So this is that waiting time simulation where I'm going to keep going until I get a 0 or a 1 that represents getting a Simone Biles picture. Okay? And if it asks me, how many do I need to buy to be pretty sure? To be really sure, we take our maximum in our trials. If I want to be really sure, I'm going to use the maximum number because there was a trial that took me 5 or 7 or 8 boxes to get it. And so that's when you're going to be really sure. If it asks how many boxes on average do you need to buy to get a Simone Biles, then you're averaging them. Okay, so let's do this one. We're still simulating buying cereal and getting a picture. We are still letting 0 and 1 be Simone Biles. Those probabilities haven't changed. And 2, 3, and 4, Megan, and 5 through 9, Serena. We're going to use a random digit table 1 digit at a time. Okay, until, instead of saying in blocks, until we get a Simone picture. Okay. So this one can go a lot faster on the random digit table because it's like, no, all you're looking for is a 0 or a 1, right? And you're going to count how many it took to get there. Our random response variable is the max number of boxes it took because it said how many, so I can be really sure, okay, or pretty sure. And then we'll go to our random digits in a second as soon as you write these down. Okay. So, 109. So, is that big enough? I'm going to go to 109. That's a no, yes. How many? 3. Yes. That's a 1. No, yes. That's 2. Remember, I'm only looking for a 0 or a 1. I don't care whether it's Megan or Serena. I just want that Simone Biles picture. Okay? So I'm like, Serena, Megan, I got them, right? You got the Simone. You're so excited,
So
right?
We skipped the second 0, right?
No, we need to find Simone. This one, I believe, says do 10 trials.
No, we just skipped the second 0.
No, the second 0 is the second trial. I got it on the first time. So my first trial is like it's 3, 1, and 2. Because on trial 2, when I got the 0, that means I opened my first box and I got it. Right? Then, no, right? This is a no, this is a no, this is a no, this is a no. There's a yes. So that took 5 this time. So my trials are 5. Yes, each trial could be a different amount of numbers because I'm going until I get that one thing, right? Just like when we were shooting free throws until we made it. Someone had 15. Some of you had 0 or until you missed it. Okay, so what's this one? No, yes. So that's a 3. So 5, 3, no. No. So far, that's 5, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. You got to really want that picture to buy 22 boxes of cereal so you can have that picture. And then the next one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Woo! That one took 17 boxes to get that picture. That's commitment. A lot of bowls. It better be Cinnamon Toast Crunch.
That's the best one.
It's the best cereal. Period. The best. Oh, and look, this time we got it on the first try. Right? anything can happen. This is a random variable simulating, right? So then our trials 22, 17, and 1. That's only 8. I need one more trial. Where am I?
You need 2 more.
2 more. 1, 2, 3, 4, 5, 6, 7.
Uno más.
7, 3. Okay, so if I want to be pretty sure, I want to be really sure, I would buy 22 boxes, and there's probably one in there.
22.
Right? If I want to know on average how many might it take, I would average up my numbers. Okay, and find the mean. So based on our simulation, if I want to be really sure I'm going to get a Simone Biles picture, I'm going to buy 22 boxes of Cinnamon Toast Crunch.
That's like a good 200.
Yeah, you had cereal for a long time. One of the things we need to notice is that it's only asking you to do how many trials? 3 trials, okay? It is not asking you to do 20. And this is, right, this is exactly from the exam that year.
Not that many trials.
Only 3 trials. It's not going to be a great simulation, right? But it's going to tell us if you know what you're doing, right? That's the point. So, every Monday, a local radio station gives away coupons to 50 people who correctly answer a question about a news fact from the previous day's newspaper. The coupons given away are numbered from 1 to 50. The first person receiving coupon 1, the second person coupon 2, and so on, until all 50 coupons are given away. On the following Saturday, the radio station randomly draws numbers from 1 to 50 and awards cash prizes to the holders of the coupons with these numbers. Numbers continue to be drawn without replacement until the total amount awarded first equals or exceeds $300. So that means if they gave away $299, are they going to pick another winner?
Yes.
Yes. It needs to equal or exceed 300. Okay, so that's important information. If selected, coupons 1 through 5 have a value of $200. Coupons 6 through 20 each have a cash value of $100. And coupons 21 through 50 each have a cash value of $50. Okay, so our numbers are going to represent the coupon, right? So I have 2 options. I can use all of the numbers from 0 to 99. Or I can only use 1 through 50 and ignore everything above 50 and ignore 0, 0. Okay. Like, I'm only want to use 50 of the numbers then. So I could use 1 through 50. I would ignore 0, 0, 0, because if I'm going 2 digits at a time, which I have to do, right? I have to do 2 digits at a time because I have 50 numbers.
So wouldn't you do 0, 0, 49?
For what? I could do 0, 0 to 49, but I don't need to. I can take, because my coupons are numbered 1 through 50, I can just use the random digit table and just use 1 through 50.
If you do use the 1 through 50, like disregard numbers, do you have to say that?
Yes, we need to state what numbers we're using and what numbers we're ignoring. Okay, and so because we didn't finish the example about picking students for speakers, we're going to do it that way. Okay, I sometimes feel like it's easier than trying to divvy up the numbers amongst all 100 and then possibly getting your percentages wrong.
Make every number worth 2?
Yes, you would. Well, you would, like 1 through 5, you would make 10 numbers be 200 instead of only 5 numbers being 200. So you would make 0 through 9 be $100 instead of 1 through 5. Okay, so it says explain how you would conduct a simulation using a random number table provided below to estimate the distribution of the number of prize winners each week. So again, you need to make sure that you're communicating your process clear enough for the person who's grading your AP exam to see if you did what you said correctly. Okay, and we have to make sure we set up our percentages correctly. So the first thing we're going to do for A is we're going to let 1 through 5 be a $200 winner. We're going to let 6 through 20 be $100. And 21 to 50 be $50. And we're going to ignore 0 and then 51 to 99. There will be times that your percentage is just weird. Like when we did the example, there's 33 students in class. Well, I can multiply numbers by 3, or I can just use 33 numbers and ignore the rest. Okay? And we have to know how to do that. That's really easy on the calculator. You just say use 0 to 33. Or on the calculator, you just use 1 through 50, because you can give it a lower bound and an upper bound. On the random digit table, though, we have to work with what we have. Okay? So we have to say that we're ignoring that. Yes, Georgia?
How come we're ignoring 0 to 2?
Because that would, if I included 0 to 5, that would be 6 numbers, not 5 numbers, and there isn't a ticket that says 0 on it and is going to award $200. There's only tickets with numbers 1 through 50 on it. So it has to replicate reality. Okay? So now we're going to use a random digit table, or random digits given how many digits at a time? 2 digits at a time. Because we have 2-digit numbers, right? The only time I can do 1 digit at a time is if I've set up using only 0 through 9. But I'm using 1 through 50, I go into 2-digit numbers. Until the total given away is greater than, not equal to, greater than $300.
It has to be greater than?
Has to be greater than. It says it first, greater than or equal to. Yeah. Equals or exceeds. Sorry. There's another one where it says exceeds only. It has to be greater than. How would you conduct a simulation to estimate the number of prize winners each week? So what are we going to record?
Prize winners.
How many people won, right? So we're going to record how many people won each week. Each trial represents a new week, right? That's part A. Set it up. A response variable is that, recording how many people. And then we're going to calculate the average number of winners. Okay, what are you going to calculate at the end? We're going to calculate the average number of winners. Yes?
I don't fully understand the total given away is greater than or equal to 3.
So when I pull up the first number, okay, let's start our trials. It'll start making sense. 7. How much does the person who has 7, what? Oh yeah, you're right. Sorry, 72. 72, that's an ignore, right? 74 is ignore, 91 is ignore. Okay, here's our first winner, 33. So that person has the card that has the number 33 on it. How much money did they win? $50. Okay, so we're going to add up how much money that we're going to stop when the total amount of money they've given away is 300 or more.
We're only giving away $300.
300 or more.
So we have to get to 300 3 times, right?
We have to get to at least 300. It's okay if it goes to 325, or it's okay if it goes over 300, right? But it can't be under 300. The total cannot be under 300. So I can't stop at 250, right? If I have like 3 winners and they have $250 given away, and my next winner is $200, they still get their $200. I'm not going to say, oh, well, I'm not to the $300 mark. You only get 50. They won $200, and the total given away was more than 300, right? If Lily won $100 and Michael won $100 and you won $50, that's $250 given away, right? I'm going to keep going and pick a new winner, okay? If Audrey gets pulled and she wins $200, she still gets $200 because that's over 300. I'm not going to say, oh, I can only give 50 away now. Right? We're going to give away at least $300.
So since it says perform the trial 3 times, you have to get to 300 or more 3 times.
3 times, yes. Okay, so 47. That's 50. 65 is ignore. 3 is 200. So that's the end of my trial because I gave away $300. Trial 1 is how many winners? 3 winners. Now, here's where it gets like to getting different answers. Do you start on the next line or you just keep going?
I keep going.
Okay. I keep going, but sometimes they'll say, note that it says, start at the leftmost digit in the first row of the table and move across. Okay. Make your procedure clear so that someone can follow what you did. That's marking, like these are the ignore numbers. This number is 50. See how I'm writing on the numbers to show what they mean? That's what they want to see. You must do this by marking directly on or above the table and report the number of winners in each of the trials. So it doesn't tell us whether we have to start over again. So we're just going to we can keep going. So 02 is the next winner. 200. 61 is an ignore. And then 28, that person wins 50, 49, 50. That equals, right? It says equals or exceeds. So that equals, so again we have 3 winners. And my next number is 90. I'll ignore it. 67, I'll ignore it.
Wait, what?
6.
The next number is
Oh, I drew my line in the wrong spot. Okay, so my next number is 6. So that's $100, right? And then 70, I ignore. 29 is 50. And 4 is 200. See how I'm over 300? But I'm going to stop, right? I don't have to say, oh, I can only give away a $50 winner. So I again had 3 winners. Okay, so that marks that up, and then you write your conclusion for B, based. And remember that these are printed to make it easier for us to hand out to everybody. Like on the AP exam, you get space to show your work in between parts A and B and C and all that. So it's not going to be so crammed on the AP exam. These are just made to be worksheets for us. So based on my simulation, the radio station will have an average of 3 winners each week. We don't necessarily need you to show us 3 plus 3 plus 3 divided by 3 equals 3,
no.
right? So it's important to make sure your answer is in context, right? What are we talking about? The radio station giving away money to winners, okay?